Well, good morning, everyone. Thanks for coming out. First talk of the morning, so hopefully you've all gotten enough coffee, and we'll start right in on how to deliver fast and beautiful images on the web. Real quick introduction about me. I'm Doug Sillars. I'm originally from the States. I lived in Seattle for 15 years. I'm currently a digital nomad traveling around Europe with my family. I do freelance developer relations, and I got started on working in the web and native to help people make their apps and their websites faster. I wrote a book for Android developers. If you're interested, you can download the PDF here. I'll post the slides, so don't worry about if you don't get a picture of the URL. I do a lot of workshops helping companies and people build faster websites, build faster apps. If you ever want to talk about any of that stuff, I'm the only Doug Sillars on the internet. I'm pretty easy to find. And so when I talk about speeding up the web, people say, well, why do we care about that? So I'm going to go with an analogy that has nothing to do with the web. And I'm going to talk about images. So one fun thing is I get to share pictures of cool places I've been. How many of you get a little terrified thinking about walking across this walkway that is literally nailed to the side of an Alp? Right? Yeah, right? Just about everyone in the room. And when we did this is in Grindelwald, like the bad guy in Harry Potter. When we walked across this, my 6-year-old daughter decided to jump across the thing, so we had this nice rattling thing going on as we were walking across it. But this relates to performance in that about 3 or 4 years ago, Ericsson did a study, and they put sensors on people's heads, and they were measuring stress responses to different things, and they found that people had a raised stress response when they were queuing up for a line, and people had a raised stress response when they were thinking about standing on the edge of the cliff. But interestingly, a slow mobile website is more stressful than standing on the edge of a cliff. So that feeling you all just had a minute ago, thinking about standing on the edge of a cliff, is what our customers feel when we build slow experiences. And if you start thinking about how people buy things, like the mall is always really brightly lit and there's always happy music, because if you're happy, you buy more stuff. But if you're frustrated, guess what? Yeah. There's a lot of data about this. Google found that a 3-second delay on a mobile website causes you to lose 53% of your customers. They just bounce. A half-second delay on a website, they found increased frustration and lowered engagement. And then this study from like almost 20 years ago, Amazon and Walmart both found that a 100 millisecond delay causes loss in revenue. But my favorite stat is that 4% of mobile users admit to throwing their phones. And this isn't like that Finnish contest where people like try to throw their phones. People actually admit to throwing their phones when there's a slow mobile experience. So what can we do to speed up experiences on the web? And if you look, this is a random 10,000 websites from earlier this year. And I just broke down like what's the tonnage on these mobile websites. And you can see, we've got a lot of JavaScript, we've got CSS, right? But just about every single website is about 50% images. So this is 10,000 websites just randomly selected. Images make up a huge amount of the tonnage of data that's sent on our website. So what can we do? If we can optimize the images, we can make our web pages load faster, or our native apps. I'm going to say native app. I may say web pages, but it works for native apps. Like anything we can do to deliver smaller images over the network. So let's talk about 4 simple image optimizations. Does anyone know Lighthouse? A few hands. All right, so Lighthouse is a tool from Google, and it analyzes accessibility and performance attributes of your web page. And inside Lighthouse, there's 4 simple image optimizations. There's quality, format, sizing, and lazy loading. And we're going to go through what those mean and how we see it on the web. Web page test fans? Anyone? A few hands. All right, so if you build web pages and you're interested in performance, webpagetest.org is like, oh, it's not a, there it is. All right, sorry. Webpagetest.org is this great web page. You can test to see how your web page loads. There are instances all around the world, so you can see how your page loads in San Francisco, in Virginia, in Singapore, right? You can actually see what the web page looks like to your customers all around the world. It's free, it's open source, it's really like the coolest tool out there. Built on top of that is a tool called the HTTP Archive. And what this does is every month it runs web page tests on 5 million web pages, mobile and desktop. and then puts all those results in a database that you can query, and you can see what the web is built of. And so what's really cool is the HTTP archive has Lighthouse results for 5 million web pages. So we can actually see what's out there on the web today, and we can see how people are dealing with quality, format sizing, and lazy loading. So let's talk about quality first. Lighthouse recommends that you save all your images at 85% quality. And so if you're in Photoshop, when you hit save on a JPEG, you see the quality bar and you can lower the quality. And obviously when you lower the quality, you're lowering you're lowering the number of pixels on the screen. You're actually lowering how nice the picture looks. This is a lossy compression. But what Google found is if you save your image at 85% in general, it's going to look great, and no one will know the difference. And the other cool thing about 85% is it generally makes the size of the image half of the original size. There are a couple other ways you can do it. You can use Image Magic, which is a free open source command line tool. And here I'm saying quality 85, just save it as a quality 85. Cloudinary is a cloud-based tool. You upload the full-size image, and then you add a parameter in the URL, and it saves it as a quality 85 image. So what does that look like? This is Riga, Latvia, 3.6 megabytes, and I save it at 85%, and it's half the size, and it still looks awesome. Right? So we've made this image smaller. It's going to get delivered faster, and nobody's the wiser, other than the page seems to load faster. So a year ago, I looked, and so 0 is bad. A third of the web was failing this a year ago. They changed the scoring, and now still 33% are failing, right? Scoring less than a half, 48% are passing. The median web page here that is failing, if they save their images at 85%, would be 3.7 seconds faster on mobile and use 130K less data, right? That's an easy performance win. If you look at these folks down here at the bottom, we're talking like 1.6 megabytes less data, right? Huge performance improvements. But 85% is just a number that kind of works for most images. What if we went a little bit better? And if I go to 50%, sometimes you can see some kerning up in the sky. I can't tell if we can see it here. At 20% for sure, you can see this image looks horrible, and you wouldn't want to use this on the web. But where's that sweet spot? Can we go lower than 85%? So we know 85% is generally good. We know 20% is bad. But there are actually tools that will find the perfect spot. Google has a tool called Booter-Augli. All the compression engineers at Google live in Switzerland, and they name all their compression algorithms after pastries. And then the other tool is called structural similarity. And so what I'm going to use is structural similarity here. There's an open source tool that I used right there. I used Cloudinary to quality auto. And what this does is it lowers the lossy compression until the human eye can see a difference. So if you're removing pixels and no one can tell, like, you're probably okay. And when I do that, this was 1.87 megabytes at 85%. So I saved another 400 kilobytes, and the image still looks awesome. Right, so I saved 400 kilobytes. That's great. If I run these images through web page test, what you can see is it goes from 21.7 seconds down to 9.5 seconds. Right, we're speeding up the load time of this image dramatically, and there's no impact to the end user. It still looks awesome. Other things we can do, we can look at the format of the image. So there are a lot of different image formats out there. If we look, this is some older data, but JPEG by far is the king of the images on the internet, but it's also like 25 years old, right? This is an old image format. It's been around a long time. Let's talk about SVGs for a second. Vector graphics are really, really awesome, and you should use them if you can. So they're images drawn as shapes. So they're vectors, right? And they're infinitely scalable. So this is the Twitter logo. And if I stretch it, it looks awesome at no matter what stretch you do. If you see any pixels here, it's because PowerPoint doesn't support SVGs, so I had to take screenshots of my SVG. Yeah, all right. You get the idea. But they look great at any size that you stretch them. So I found a website that was using this SVG as sort of a divider. And something was wrong with it, and so I wanted to see what was going on. And it's XML, so I can open up the XML and look to see what's inside. And you can see up at the top here, you can see it's drawing circles and things like that. But at line 30, you see it says Adobe Illustrator, and then there's all this metadata. I'm like, ooh. The file was 946 kilobytes. And the fix here is you click on line 30, you drag to the bottom, you press delete, and then you hit Command S. And when you do that, it becomes 1 kilobyte. This is sort of a testing thing as well. Like if you see an SVG on your web page and it's 900 kilobytes, something's wrong, and you should fix it. Obviously, then you can compress. It's a text file, so you can compress it to 600 bytes, or you can use Google's Brotli, right? Bread. You can make it 500 because it's a newer compression algorithm, so it gets a little smaller. Now, this website not only had a red sort of target logo, it had an orange one as well. Now, for those of us who are web developers and do CSS, you can style the red one and turn it orange with CSS. Or you could go their approach and download 1.8 megabytes of circles. Right? This is kind of an obvious thing. If you can get it down to 500 bytes and 2 lines of CSS, that's going to be a lot faster. Let's talk about PNGs. PNGs are an awesome format. They're really, really great. They have transparency, just like GIFs, so you can, they can be see-through, so you can overlay them, and it's really awesome. But I found one use case over and over and over on the web that isn't an ideal use of PNGs. And so this is from Chrome DevTools. What's your image processing pipeline look like? I tweeted. Those of you who use Macs may recognize this file format of screen_shot_year, month, day, time. Right? They got the image perfectly centered on their computer, and then they took a screenshot. And then they pushed that live onto the internet. Screenshots are awesome. Like, this is a screenshot of my tweet, and I put it into my PowerPoint. Like, that's awesome. But when you're putting things on the web, we should look at optimizing these files, and these files are not optimized to go up on the web. I actually went and found 3,000 images with the term screenshot in it on the web. And I wanted to see if I could optimize them. And so I turned them into JPEG. I went to quality 85. And 86% of them got 50% smaller. And 35% of them were 10% the original size. Like, if you can take all your images and make them all 10% the original size, like, that's a huge performance. Those are going to download, a lot faster. Another thing to look at is WebP. It's a newer format. It's been around for about 5 or 6 years, maybe 7 years now. And if I gave this talk about a year ago, support was just starting to come out on other browsers besides Chrome. So this was a format from the Google side of things. But if you look now, we do have it in every major modern browser except for Safari, and they are actually working on adding it. There's activity happening in their bugs right now to add that. So WebP files are generally a lot smaller. You save more data by doing that. And so if we look at this Riga photo, again, it's another 400 kilobytes smaller just by switching the format to WebP. Obviously, not all browsers support that. Some of us have to, Safari obviously is a very important browser. How many people here still support IE browsers? Right? Yeah, obviously, that's about half the people here. So for things like that, you can use the picture tag where the WebP is first, and if the browser doesn't know what to do with the WebP, it falls back to the JPEG. Now that WebP is going to save us another 2.5 seconds in download. So we're still speeding up this image. It's getting faster. It's downloading faster. Let's just jump to here. So this is this year. Only 18% of the web is passing this Lighthouse score. And 62% is failing. Of those sites that are failing, we're talking 6.5 seconds faster, 140K less data. The folks down here at the bottom, the median website here would save 2.4 megabytes and be 15 seconds faster. Now, if you think about that, the median website is at 13%. That means that 13% of the web would save even more than that, which is astounding, right? Like 13% of the web could save more than 2.5 megabytes just by changing the format. Image sizing. This is sort of responsive images. This is what everyone kind of gets. Like, you serve different images to browsers that are used on the desktop than you do to people on their smartphones. And so as an example, here's a picture of a cathedral in Serbia. The original image was 13 megapixels, is 1.6 megabytes. I did all the stuff we just talked about, and it went down to 800K, but it's still 13 megabytes, or 13 megapixels, excuse me. So if I download that onto a small little phone, you have 13 million pixels, only 500,000 show up on the screen, so you end up throwing away 12.5 million pixels. And so this is essentially a double taxation on your mobile users. They have to download the whole thing, then the CPU has to fire up and throw away 98% of the stuff that it downloaded. The closest analogy I can come to that is when you buy something from Amazon and you have to go through like 6 meters of brown paper to find out that your kids ordered a pencil. Right? We're doing this to our customers on the web today. Now, to make matters worse, to do that image decoding, to throw away those millions and millions of pixels, it takes time. And so this is an example I did. It was 16 million pixels down to 1 million pixels. And on the desktop, it took 78 milliseconds for that image decode to happen. On a Motorola G4, which is sort of a mid-range Android device, it was a high-range device a few years ago, sort of mid-range now, we're talking 200 milliseconds for that to happen. The Alcatel One X is an Android Go phone. It was sold last year. I think you can still buy it this year as well. Extremely popular because they're like 40 euros, right? These are phones that people can buy, and if you give them to your kid and they drop it down a drain or something, it's not a huge issue. But it takes 820 milliseconds to decode that image. So it has to download the whole thing, and then it takes almost a whole nother second to get it onto the screen. And when the CPU is running, of course, now your phone is getting warm, right? Because the battery's draining faster, right? This is something where people start to notice that the performance of the web page is slower. There are a lot of Android devices on the market today. This slide is actually about 1.5 years old now. These are all of the Android devices that hit Akamai in one day. The size of the box is how many of each one, so these are all Samsungs. The color is how fast the processor is. We've got a lot of really slow Android devices out there, so we need to make sure that we're serving the right size image to those devices. So how do you do that? Responsive images to save the day. This is something that probably a lot of you are familiar with. In this case, I generated a set of images that were 25 kilobytes apart in size. In the picture tag, I set up I tell it what width, and now I'm only throwing away 100,000 pixels. A lot better. It's going to download a lot faster. It's going to look great. And so the tool I used was a responsive breakpoint generator. I just said, give me a bunch of images between 200 and 1400. Make them 25 kilobytes apart, and just give me a zip file. You can also, there's a GitHub repo, so you can actually incorporate this into your image processing pipeline. There are a lot of ways to do this. You can look at your analytics and see which size devices you have, and maybe you only need 4 or 5 sizes. Maybe 25 is a lot. It is a lot. But in this case, now I've got the optimal size image for my mobile device. And what we can see here is when I run it through web page test, the load time drops from 7 seconds down to 2 seconds. And now it's only 121 kilobytes. This is reasonable. We now have a reasonable size image that's going to download quickly and still look awesome to our customers. Responsive images, a year ago, 57% of the web passed. This year, we're at 58%, so really no change. And again, a quarter of the web is failing. We're looking at about 1.5 seconds faster if we could make our images responsive to mobile devices. Again, for these people down here, the 8% that are completely failing, we're looking at 2.5 seconds faster, or 2.4 megabytes, 14 seconds faster, excuse me. So lots of ways we can take individual images and optimize them and make them look awesome. Lazy loading is another process we can take. This is now something that we put over our whole web page. And so the idea here is if you have a web page that looks like this, you only load the images that are in the initial viewport, and then you lazy load the other ones as people scroll. Now at load time, instead of 6 images, we only have 2. The web page is going to load faster. Lazy loading has really taken off. Last year, only 22% of the web was passing, and this year it's 56% of the web. Like, a lot of people have implemented lazy loading. The folks that have not could save 300K, 3.1 seconds on their mobile site. And again, the people down here, at the 10% level, scoring a 0, we're talking 12 seconds faster. So what do you do when you lazy load the images. A lot of websites do preview images. So in this case, this is a Google image search on my phone, and Google gives us single color SVGs that denote that an image is coming. And you can actually see they color code it based on the most important color in the image. So here I am searching for cats in costume, and you can see the crocodile one gets a green, the cat dressed up as a bunny rabbit gets pink, right? So the SVGs kind of match up to what's showing up on the screen. If you want to go a little fancier, there's some cool libraries that will actually sort of give you a textured look to the SVG. This is, again, just 900 bytes. It can be your background image. Then when the full-size image comes in, it just replaces it. And so people have kind of become used to this pattern, right? Medium does it, Facebook does it. It's out there, and people understand what's going on, and they know what to do with this. So I built a really slow web page. This is the desktop view, and each one of these lines is showing, a viewport. And so when I loaded this in Chrome a few months ago, this is what happened. You got the text initially, and then you can see slowly the images are coming in place. But what's interesting, if you look at number 4, the image is at the top of the screen, where as a user, you're sitting and waiting for the images to come in. You can see there's a gap. You're waiting for something to come in. Yet there's a picture of a cow about 2/3 of the way down the screen that is fully loaded and ready to go. But nobody cares, right? Because we don't care about the cow. We want the stuff up at the top to load. So what's happened now is Chrome has added lazy loading by default. And you can add an attribute, and you can add lazy loading into, and Chrome will lazy load your images automatically. So what happens here is the entire page gets laid out. You can see by frame number 3, the entire page is laid out. I've got preview images in place. But now that Chrome knows the order of the images, they load from top to bottom, which is the way we scan web pages. It makes a lot more sense. All of the images by number 4 have loaded at the top of the page. And the cow doesn't actually appear until number 6. This is the way it should be. This makes a lot of sense. So lazy loading is, it's in Chromium browsers now, which is really exciting. There are a lot of JavaScript tools that you can add into your web page to make it work on all the other browsers as well. Now, these are the ones that are in Lighthouse, but I have a few other image optimization techniques that we can improve upon. So when I lived in Seattle, I had goats. And this is Nora. And I took a video of Nora. And the video on my phone was 1.4 megabytes. And I'm like, this just needs to be a GIF, right? So I turned it into a GIF, and that's awesome. It's Nora eating a leaf. And the problem is when you turn something into an animated GIF, it gets a lot larger, 270% larger. So actually, if you go back in history, and you go back to 1990, and you read the specification for the GIF format, it says the GIF format is not intended as a platform for animation, even though it can be done in a limited way. So like all the animated GIFs we use, like the people who built the formats, like you shouldn't be doing that, right? It's in the spec. And the reason that is the case is animated GIFs are not optimized through time. And so if you have 15 frames per second, it's literally 15 GIFs that it flips through like a flip book every second. So it's just not optimized for that. So if I actually take the video that I had and I make it 256 colors, because GIFs are only, it's 1990, we only had 256 colors. I tell my kids that and they don't believe me. I take out the sound because goats eating, not a pleasant sound, and animated GIFs are silent anyway. It's only 250K, right? It's smaller. This is exactly the way it should be. And you serve it as a video. Now, you might all be saying, but GIFs are everywhere. Like, Twitter uses GIFs, right? For those in the back, it actually says GIF down here. But what's really interesting is Twitter's lying. Open that up in DevTools, and you can see it's an MP4, right? They're serving these as videos because they're so much smaller, they get delivered a lot faster. It makes Twitter, it makes Facebook, it makes Slack faster. So all of the GIFs that you see on the web, it's sort of GIF the technique over GIF the format, right? We all love the animated format of looping videos, but don't ever use a GIF to serve a GIF. And so the way you do it is you just use the video tag, you loop it, you set it to autoplay, Now, GIFs are silent, but you still have to add muted. And that's because mobile browsers won't autoplay a video unless it's muted. And then you just put in the MP4 and it'll play. And it'll loop. And it'll look awesome. If you have a lot of users on Safari, you can actually put videos in the image tag, in the picture tag, which is kind of cool. So in this case, the browser will loop the MP4, or it will do an animated WebP. And for those that don't support any of those, it will fall back to the animated GIF. So that's one way you can do that. Of course, the animated GIF takes 22 seconds to download on a mobile connection. The animated WebP takes 18 seconds to download, and the movie only takes 4.5 seconds. So if you're really looking at performance, the MP4 is the way to go here. It's going to be so much faster to download that content. Other things we can look at is we can see, what are our customers saying? What are our customers telling us in terms of what kind of content they want? Has anyone used data saver mode on their Android? It's now called light mode. They changed the name. Basically, it adds a header that says save data on. And so that header is sent to every single server that this person hits with their browser. And so if the server says, hey, this guy wants less information, you can serve them less data. This is data from about a year ago. Tim found that 5% of his users have this header turned on. And so if 5% of your customers are saying, hey, I want smaller images, I want less video, maybe we should listen to them and we can serve them maybe one size smaller of the images, right? Just to save a little extra data. Maybe remove a few of the images. Tools like Cloudinary have this built in. So if you have it set to like the automatic quality, if they see the save data header, they'll actually go a little bit more aggressive. And in this case, it saves about 45 kilobytes. Right? We're making the image smaller to save the data for the end user. We can also look at the network. And I hear a lot of people telling me like, well, 5G will save the day, but there's still going to be a lot of people on 4G and 3G for a really, really long time. And if you're on a slow network connection, and I was just at an Airbnb where the whole neighborhood didn't have fiber yet. Fiber was coming in a month, and we were all on 3G routers, right? And it got really, really slow. And if you're on a slow connection, if your customer's on a slow connection, maybe you should serve different data. When I lived in Cork for a while, I was on a really, really slow connection, and I never got any videos in my Facebook feed. Why was that? Because Facebook knew that I was going to get frustrated with Facebook. When I went into the city, all the videos reappeared. On Twitter, the GIFs didn't animate. When I went into the city and I got fast connection, the GIFs animated. They change what content is being served based on the network speed. So there are all these there's these APIs, the Network Info API. And if your customers are on a slow connection, serve them different content to make sure that they still get that great experience, but it doesn't take forever to load. There's one more thing I'd like to bring up is base64 encoding. And the idea behind base64 encoding is you can base64 encode the images and just throw it straight into the HTML or the CSS. This is an anti-pattern now, and we shouldn't do it anymore. Maybe for SVGs that are really small, like under a kilobyte, that's fine. But for large images, we shouldn't do that. I mean, it does mean fewer requests, which was like an HTTP 1 thing when we were worried about fewer requests. But the images are now blocking the rendering of your page. The images are bigger. Base64 encoding is like anti-compression. It's harder to cache the files, right? You now have to cache the images as well. And they're difficult to reference more than once. So as an example, here's the University of Nebraska. They have this shared CSS template. It's 91 kilobytes. 48 kilobytes of this is an SVG file. It's base64 encoded, but it never appears on any single page at the University of Nebraska. This is the SVG, right? It's got the Latin logo and all that sort of stuff. And I was like, why does this not appear on any single page? And it turns out in their style guide, it actually says you should use the Nebraska N as the main identifier and never use the university seal. Yet every single web page delivers the university seal to every single one of the people who ever visits their web pages, right? Every single web page is using an extra 48, 50 kilobytes to deliver this content that no one ever sees. Just by stripping that out, we'd speed up the delivery of these web pages. When I mentioned they're hard to reference, it just looks like gobbledygook. And so this is a web page where they have the stars for like rating different objects. And they're like, well, did we add it to the web page? I'm not sure. So they just pasted it in again. 16 times the same star. This is a star image. And if you're wondering, the space in between is an empty star. That one's there 16 times too. And so this CSS is just downloading kilobytes and kilobytes of images over and over and over again that are only used once. So there are a lot of ways we can reduce the amount of tonnage that's delivered from our images. And so the way we can do that is we can optimize the image quality. We can change the format to the optimal format for the mobile device or the browser. We can resize it for the screen size. We can lazy load the images that aren't on the screen. We should turn our animated GIFs into movies. Don't base 64 encode images, and then monitor the headers of your customers. Like if they're asking for less data or they're on a slow connection, maybe serve them different content. I used a bunch of different tools to build this talk. Web page tests in the HTTP archive to get the data on how these web pages are being built. And then image magic, structural similarity. Here's some links for all of those things, lazy loading, responsive breakpoints. And then to generate a lot of the images that I used, I stored them all on Cloudinary, which is a cloud-based image hosting platform, which is really cool and easy to help do all of these things as well. So in conclusion, your images can be fast and beautiful. And with that, thank you so much. I'd be happy to take any questions. Yeah. Image resizer. Right. To resize it. So yeah, so there are a lot of tools that will resize images for you on the fly. And there are actually a lot of really cool tools now that are using AI and machine learning to figure out how to do the optimal crop. Because if you have an image where like I'm on the side and you crop it in the center, you might just have a picture of an empty stage because you cropped it and cut off the person you wanted to have in the image. So there are a lot of tools now that will actually identify things of interest in the image to do the cropping. So there are actually a lot of tools out there that will do that for you now. No, it's still really, really fast. So for example, Cloudinary can do that for you on the fly and you don't even notice it. Like it adds just maybe a couple milliseconds, but it's not noticeable to the end user. Yeah. It needs to be zoomable. That's a good point. So, some ways that happens, if one way you can do that is obviously have a thumbnail and then the big image, right? And then maybe lazy load the big image afterwards. So you get all the thumbnails in there really, really fast, and then you can lazy load the big images later. Because I guess in general, people see the small thumbnails and then maybe only see a few of the large images. You may even just, depending on how often people do it, you may actually wait until they hover over the smaller image to download that. There may be a slight delay there, obviously, but there is a cost to delivering. If you have 7 giant images and you're downloading it to every single user, there is a cost to, delivering all of that. Yeah. That's a good question. So how much does DPI matter? I read a study that the human being with the greatest eyesight ever measured would only be able to see the difference between, could not see the difference between 2 and 3 DPI. So if you want to use, there's no need to go beyond the 2x when you're doing the DPI. Like the 3x, you can do it, like certainly, but the images are going to be a lot larger, and there really isn't that much more of a perceivable increase for like 99% of the population. Does that help? Yeah. Yeah. there are a lot of fun tricks that you can do to make to play with the images for sure. Yeah, in the back. So the question is, if you can only store the big image, or I'm assuming the big image, and you want to resize it on the fly, the resizing is really fast nowadays. If you wanted to do that on the fly, I mean, obviously, it may be a little slower than having 3 images there and getting it straight from storage. But it is really fast to resize them on the fly. And to me, the advantage is if you have a 300 kilobyte image and you can make it 50K on mobile, that's going to be a huge performance impact to your end user, just because it's going to download 6 times faster, and they won't see a difference. Well, they will see a difference in that the page loads faster, but the image will still look great. Well, cool. Thanks. I'm going to be around the rest of the day, so if you have any other questions, just feel free to come up to me and we can talk about images. I'd love to chat. Great. Thanks so much.